Chapter 9, Introduction to Hypothesis Testing. In this video, we'll learn how to formulate a decision rule for testing a hypothesis, as well as using the test statistic approach for testing hypotheses of a proportion. So with hypothesis testing for a proportion, we still state our hypotheses in terms of population parameters. So you see here the lowercase p's, and our sample statistic is p bar. You're familiar with these from our previous chapters. Now, our null hypothesis will always have the equality symbol, whether it's an equal sign, a less than or equal to, or greater than or equal to. So this is very similar to hypothesis testing for a mean. Our significance level, or our alpha, determines the rejection region, just like it was in hypothesis testing for means as well. So here we have a two-tailed test. Just like with a mean, our two-tailed test will have an equal sign in the null hypothesis and a not equal sign in the alternative hypothesis. So here we're testing whether or not the population proportion is equal to 0.3. And with a two-tailed test, we have two rejection regions. If our sample proportion falls out in either rejection region after accounting for sampling error, then we reject the null and the alternative hypothesis is true. Here we have a one-tailed upper tail test, and we know that because the alternative hypothesis has a greater than symbol. And remember my hint, greater than points to the right, and so it points to an upper tail test. So here, if our sample proportion is way out in the upper tail, then we will reject the null, and the alternative hypothesis would be true. In my last example here, again, we're working with a one-tailed lower tail test, and we know because my alternative hypothesis has a less than symbol, which points to the left towards the lower tail test side. So here, if my sample proportion is so far out into my rejection region, we would reject the null. So the same logic applies just like with hypothesis tests for a mean, but now we're working with proportions. With hypothesis tests for proportions, this involves categorical values. So recall in chapter 1, we learned the difference between numerical values, numbers, and categorical values, categories. So with hypothesis testing for a proportion, we are looking for two possible outcomes, where we've got success, which has the certain characteristic that we're interested in, or failure, what doesn't have the characteristic that we're interested in. For instance, we could test for a proportion of customers who like or don't like a new product. Or we could do a hypothesis test for a proportion of items manufactured that are defective or not defective. So this should sound familiar because this is similar to the binomial probability distribution, and that we're looking at two possible outcomes, and now we're trying to test for the proportion that we're interested in. So here's an example. Amazon claims that the proportion of dissatisfied customers is less than 0.10, or less than 10%. To test this, a random sample of 100 customers is selected, and 6 are found to be dissatisfied. Using a 0.05 significance level, that's our alpha, conduct the hypothesis test using the z-test statistic critical value approach. The nice thing with hypothesis testing for a proportion is there is only one process, and we will always be working with z-values. T-values only apply to population means when we don't know the population standard deviation. So you do not need to worry about t-tests when we're working with proportions. So here we've got our normal distribution for our story. So here is the 0.1 claim that Amazon thinks less than 0.1 customers are dissatisfied. So first we need to set up our hypothesis test. Amazon claims that the proportion of dissatisfied customers is less than 0.10. The less than 0.10 is our clue. It does not include 0.10, meaning there's no equal sign. So that means our less than 0.1 is our alternative hypothesis, and our null, which must include the equal symbol, is everything else. In this case, our proportion is greater or equal to 0.1. So what we're really testing for is our proportion of people that are dissatisfied with Amazon are in this lower tail, because my less than symbol points to the left. So I'm going to be focused on the left side. So this is a one-tailed, lower tail test. We are going to test to see whether or not Amazon's claim is true. As a reminder over here to the right, this is our standard error of our sample proportion, where we take our population proportion and plug into the formula along with our n. So this is just a reminder of what you already know from previous chapters, but it applies here in our hypothesis testing. So our alpha is 0.05, that's our significance level, and our sample proportion, we had 6 people dissatisfied, so there's my 6, and I divide it by my sample size of 100. So my sample proportion is 0.06. So it's really important to make sure we keep straight our sample proportion versus our population proportion, because they are both used in our Z test statistic formula. So just bringing over what we have from the last slide, we're going to identify where our rejection region is. And that's based off of our alpha value of 0.05. So going to our Appendix F, since this is a one-tail test, you'll go up to the top where it says one tail, move to the right until you see the 0.05 alpha, then go all the way down to the bottom of Appendix F where our infinity symbol is. And you'll find our critical value Z of 1.6449, but if we round, it's 1.645. And again, we add the negative because this is a negative Z value because we're on the left side of the curve. So now that I've got my critical value, this is my decision point. So we'll know if my sample proportion falls out in this rejection region where alpha is 0.05, which translate to a critical Z value of negative 1.645, or if it's less than our critical Z value of negative 1.645, because less than is over here, then we would reject the null. If it's not less than our cutoff point and our sample proportion falls somewhere in here, then our null hypothesis is not rejected, which implies that it is true. Therefore, we do not reject the null. So here's our formula for our Z test statistic. So here, if you forget, here's our sample proportion, the p-bar. Here's our null hypothesis, or our hypothesized population proportion. And then down here in the denominator, this is our standard error for our sample proportion. So plugging in all the numbers we know from the problem, here's our sample proportion of 0.06, which we obtained by taking 6 divided by 100. And then our hypothesized population proportion of 0.10 gets plugged in everywhere else. Note, this 0.9 was obtained by taking 1 minus 0.1. We divide that by 100, square root the whole thing, and this is our standard error in the bottom of our formula. So when we take our numerator divided by our denominator, we will get negative 1.33. Now again, I always recommend drawing and using our curve to identify where our numbers fall. So take a moment and think, where does negative 1.33 fall on my number line here for my Z value? If you identified it's somewhere right around here, you're right, because negative 1.33 is greater than negative 1.645. So because our Z test statistic of negative 1.33 is not less than our critical Z value of negative 1.645, we do not reject the null. Again, because my test statistic here is in this area, not in the rejection region, we do not reject the null. And so that's our decision. Since we do not reject the null, that means our null hypothesis is true in that our population proportion of dissatisfied Amazon customers is greater or equal to 0.10. So if you're Amazon or Jeff Bezos, we have a problem because we have unhappy customers that exceed 10%. Let's look at the problem on our worksheet from our textbook, problem 30. Suppose a recent random sample of employees nationwide that have a 401k retirement plan found that 18% of them had borrowed against it last year. So if you didn't know, if you contribute to a 401k account, you can borrow against it. Now, a random sample of 100 employees from a local company who have a 401k retirement plan found that 14 had borrowed from their plan. Based on the sample results, is it possible to conclude at the alpha of 0.025 level of significance that the local company had a lower proportion of borrowers from its 401k retirement plan than the 18% reported nationwide? So here we want to know if this company has a lower proportion of borrowers. That's a context clue for us. That lower is telling us that this is going to be a one-tailed, lower tail test. So that's what you're going to look for in problems. If it says lower or less than or fewer, you know you're going to be on the left side with a lower tail test. If our story talks about greater than, more, exceeds, then we know we're dealing with a one-tailed upper tail test. So our null hypothesis is that our population proportion of our local company is greater or equal to 0.18. And our alternative hypothesis is that the population proportion of our local company is less than 0.18. Again, we get the 0.18 from the nationwide number of people who borrow against their 401k, but the thing that we wanted to test for is whether or not our local company has a smaller proportion of people who borrow against their 401k. So to get our sample proportion, we take the 14 people in the company divided by the 100 sampled, and our sample proportion is 0.14. Our alpha value was 0.025. Because our alternative hypothesis has a less than symbol, we know this is a one-tailed, lower tail test. So for our decision rule, we will reject the null if the calculated value of the test statistic z is lower than the critical value. Again, it's lower or less than because our less than symbol here in our alternative hypothesis tells us so. To get the critical value, you'll go to the Appendix F, and again, we're just working with z-values. So you're going to use that infinity row at the bottom of the appendix. So first, we'll look for our one-tail row up at the top, move to the right until we get an alpha value of 0.025, and then go all the way down that column in the Appendix F until we get to the infinity row, which tells us that the critical value z that we're going to use for this problem is 1.96. And we make it a negative 1.96 because this is a lower tail test. Our appendix is not going to tell us if it's negative or not. You have to include the negative sign in there based on your knowledge of lower tail tests. Let's go ahead in part B, find our calculated value of the z-test statistic. So here I'm going to take our sample proportion minus our hypothesized population proportion, and then here's our standard error, which is based off of our hypothesized population proportion of 0.18. So I'll plug in my 0.18 where the p's were, and my n here of 100. So solving across, my sampling error when I take 0.14 minus 0.18 is negative 0.04. And our standard error when I plug in my hypothesized p and my n, I get 0.0384. Then by dividing the two numbers together, we get a z-test statistic of negative 1.04. Now we have to make a conclusion about our hypothesis test by taking our number in part B and comparing it to our number in part A. So because our z-test statistic of negative 1.04 is not less than our critical value of negative 1.96, we do not reject the null and can conclude that the proportion of employees from this local company who borrowed from their 401k plan is not less than the national average of 18%. And so when we're working with our conclusions, there's a few pieces, right? So this first part here, we're comparing the numbers in part B and part A. So we can see that this negative number is not less than that negative number. Or you could have written that negative 1.04 is greater than negative 1.96. And greater than does not match our decision rule we had listed in part A. Then after we compare the numbers, that's going to clue us in as to whether or not we reject the null. And again, here up here, we said we would only reject the null if our test statistic was less than the critical value. And since it's not, we will not reject the null. And then it's important that after you make the decision on whether or not you reject the null, we have to be able to explain it in layman's terms, what it means in terms of the story. So this latter part here of our statement talks about the employees versus the national average. So if you have any questions, just let me know.